Okay, I'm good to go, right? Okay. Hello, everybody. I want to welcome you all to today's class. I'm really very, very happy to be hosting all of you in today's class. For those of you that don't know me, my name is Mr. Samuel, aka popularly called Mr. Life Changer. Okay, and I decided to give back to the society through this medium. I will be having this class every Tuesday. It's going to be a series. So every Tuesday, same time, I'm going to be having this class. What that means is that you can share to your friends, invite as many persons as possible. This is going to help a lot of people. It is free, and the more they join, the better it is. I wish you all the best. Okay, so let's begin. Today, we are going to start with electron emission. We have been seeing the flyers flying around. So we are looking at electron emission. Okay, and what is electron emission? Electron emission is simply the emission or ejection of electrons from the surface of a metal. Now, what that means is that electrons can be ejected, can be emitted from the surface of a metal. Now, I want to bring us to a particular idea we may have forgotten about metals. Now, metals, one thing we know about metals is that metals is characterized by free mobile electrons. I'm sure you can remember that, free mobile electrons. What that means is that the electrons in metals are actually allowed to move freely. They move, mobile. Now, these electrons can be directed for other uses. And the way that can be done is by it being emitted from the surface of the metal. And that is what we are going to be looking at. Today is going to be a very interesting, day, a very interesting topic. Now, there are 4 ways by which you can emit electrons from the surface of a metal. And one of the emission is what we call thermionic emission. Thermionic emission. I hope you have your writing materials. Okay? The first one is thermionic emission. The second one is called photoelectric emission. And I'm going to explain all of that. Okay, the second type of emission from the surface of a metal is called photoelectric emission. The third type of emission from the surface of a metal is called field emission. Okay? And the fourth type of emission from the surface of a metal, number 4, is called the secondary emission. The secondary emission. Okay? So these are the 4 kinds of emission. And by the grace of God, today we are going to be starting with the first one, which is thermionic emission. But before I go into that, I want to quickly give a brief summary about each of these emissions. Now remember that you need a sufficient kind of energy to be able to emit electrons from the surface of a metal. The energy needs to be high enough, okay, for electrons to be emitted from the surface of a metal. Now, in the case of thermionic emission, the energy you need here is heat energy. So when you heat metal and the energy generated becomes enough or sufficient to eject electrons from the surface of a metal, we call that type of emission thermionic emission. Okay? And in the case of photoelectric emission, this one requires light. Now we call it light, we also call it photon. So we say light or photon. You have the comment section in case you observe anything, you can always type, and so that I can always get feedback from you guys. Okay, so we have light or photon energy. So light energy, just like you have your solar panel and all of that. That is another topic we are going to be looking at in this very series. Now, in the case of field emission, is when electric field, electrons are emitted from the energy that comes from electric field. Now, what is electric field? Electric field is a type of field force. It's that type of field that is generated when you have a positive charge and a negative charge, you have a positive charge and a negative charge placed side by side. Now, whenever you have a system like this, it always generates a field. Electric field always moves from the positive side to the negative side. That's the direction of electric field. Now, if I placed a metal now inside this electric field, and the energy from this electric field is sufficient enough, remember, I keep mentioning sufficient. The energy has to be sufficient. That is what we call work function. The minimum energy required for electrons to be ejected from the surface of a metal. But we are going to we'll look at that as we continue. So if this electric field has sufficient energy and the metal, it passes through the metal, electrons will be ejected from the metal surface. Electrons will be emitted from the metal surface. I believe I make sense, okay? You can be commenting to be sure you are understanding. So what is responsible for field emission is called electric field. And for secondary emission is emission that is as a result of electrons. Now these three emissions, thermionic emission, photoelectric emission, and field emission, the three of them fall under the category, you can call them primary emission. Now, when electrons are emitted from the metal surface, and that electrons goes to hit another metal and causes more electrons to be emitted, that is secondary emission. So, I would put it this way. Let's say this is a metal surface. Electrons are ejected from a metal surface. Then the electrons goes and hit another metal. This is metal 2. Let me call this metal 2. And let me call this metal 1. Okay, so electrons from this metal surface goes to hit this, causing electrons to also be emitted from this. So the electrons from this metal hit this metal and causes more electrons to be emitted. That kind of emission is what we call secondary emission. So we can say the purpose for, the cause for secondary emission are electrons. Now, but I will also say this because I know we have different classes of students that are here. Now, if your exams, you're preparing for WAEC, NECO, JAMB, major exams, then your major interest is these two. Yeah, we are going to look at this secondary because X-ray is a product of secondary emission. Actually, X-ray itself is as a result of, is a product of secondary emission, and we are going to talk about that when we get there. Okay, so for now, we will be looking at thermionic emission, okay? And I believe that makes sense. So let us go back to the first one. Okay, so thermionic emission. Okay. So what is thermionic emission? Thermionic emission is simply the emission of electrons from the surface of a metal by heating the metal. So the energy here that is responsible for the ejection of electron is what we call heat energy. Okay? And this thermionic emission is actually quite very important, but these days is not that relevant because technology has advanced, but the reason why we study some of these things is because they still remain the bedrock of whatever we have now or whatever we know now. So under this thermionic emission, we are going to, okay, maybe I should give the principle of thermionic emission. First of all, three things are needed here. The first one is what we call the heated cathode. We call it the heated cathode. So there are always two ends. One end is called the cathode. The other end is called the anode. So the heated cathode. So the metal here that will be heated is the cathode. Then we have the anode. Okay. Then we now have, let's call it tube. The tube or the tubing where all of that happens. Then I think in most of the cases, in fact, in all of the cases, we also have, I will call that voltage or potential difference. Or I think the best word to use here for potential difference is what we call applied voltage. So when voltage is applied, the idea is that voltage is applied, The voltage applied hits the cathode. Once the cathode gets heated to a particular point, it emits electrons and, to the anode. So electrons always move from the cathode to the anode. Now the question is, what are the things we are going to study under this? This is a summary of everything I'm going to be mentioning here. Now, those electrons that are emitted from the cathode are what we call cathode rays. I know some of us are familiar with that. A lot of us should be familiar with this. So we call them cathode rays. So one of the things we are going to be studying here are cathode rays, the properties of cathode rays. What makes cathode rays cathode rays? I hope I am making sense. Okay, then other things that we are going to be looking at here, because there are applications of thermionic emission. One of them is what we call, we can call that, we are going to be looking at discharge tube. We'll call that discharge tube, okay? We're going to be studying discharge tube. It's examinable. By the end of this class, I hope to go through certain past questions, to confirm what we have learned. So we are going to be looking at discharge tube after the cathode ray. Then secondly, we are going to be looking at what we call diode valve. I know you should have heard of this, diode valve, or what we call, diodes, okay? You can also call them thermionic diode. It's part of what we are going to be looking at here. Thermionic diode, okay? Now the third thing we are going to be looking at here, number 3, after thermionic diode, is what we call cathode ray tube. Cathode ray tube. Or simply, actually, cathode ray tube is contained in what we call cathode ray oscilloscope. Cathode ray oscilloscope. Now, these are the things that we are going to be measuring on. We are going to be, we are going to be measuring on. These are the things we are going to be looking at, okay? And these 3 things that we are looking at are not the only things that thermionic emission is needed. There are other aspects. Let me list them, but we are not going to study them. One of them, we will study them like X-ray. Actually, the production of X-ray starts with thermionic emission, but we will get there, that will be later on. Now, even your TV tube, I know some of you will be wondering which TV tube, what we have now at Gen Z is you have flat screen. But in those days, when TV bus came, it used to be very long. That tube actually operates with the principle of thermionic emission. Actually operates with the principle of the cathode ray tube. Okay, so you have your TV tube, you have, there are a lot of them like that, the principle of thermionic emission works. The only disadvantage of thermionic emission is that you need heat. And that makes the disadvantage. That's the reason why technology, a whole lot has been discovered in order to cover for that lapses. Okay? So now we are going to go straight into the first. Let's talk about, let's talk about cathode rays quickly. So what do we know about cathode rays? Now, I want you to note some of these things because these are what you should expect to see in your exams. Cathode rays, quickly. Okay, so what are cathode rays? Cathode rays are rays that are actually rays that emanate from the cathode. In the real sense, cathode rays are electrons. So if I want to talk about the properties of cathode rays, I will say number 1, they are streams of electrons. Cathode rays are simply streams of electrons. That's the first thing I can tell you about cathode rays. They are stream of electrons. Okay? So, and number 2, maybe I should also mention this here, is that they emanate from the cathode. They emanate from the cathode. So the reason why they are called cathode rays is because they emanate. Their source is the cathode. The cathode is what is heated, then produces cathode ray. So the second property of cathode ray is that they emanate from cathode. Now the third thing I would like to mention here is that they are negatively charged. They are negatively charged. So that is another property of cathode rays. Number 4 properties of cathode rays is that cathode rays they can cause certain substances to fluoresce. Now, what do we mean by causing certain substances to fluoresce? It simply means, from the word fluorescent bulb, it simply means that they can cause certain substances to show light. Whenever you watch your TV, your television, especially the old one, the box TV, many of you know what I'm trying to describe. Whenever you see it showing pictures, it is simply fluorescing. It is cathode rays that, I will show you the technology as we continue, that actually hit certain signals and brings out those beautiful pictures. So cathode rays can actually cause certain substances to fluoresce, to show light. In those days, right now we have energy saving bulb. In those days, we have what we call fluorescent tube. And when you look inside, when you take a quick look inside the fluorescent tube, you will notice that there are certain materials that is coated inside it. Just take your time and look at it. Now, the reason for those coating inside the fluorescent tube is so that when these cathode rays hit the fluorescent tube, it will fluoresce. To fluoresce means to give light. It begins to give light. I hope that makes sense. Okay, another property is that number 5, it can cause certain substances to ionize. It can ionize certain substances. It can ionize certain substances. So that is another property of cathode rays. It can ionize certain substances. What that means is that it can produce ions. When you say ionize, to ionize means to make a substance to either be positively charged or to be what? Negatively charged. So charges are everywhere. We are a product of charges. We see charges everywhere. Okay, so one of the ways to produce charges is by exposing an object or exposing a substance to cathode ray. It can cause substances to ionize. Okay? Another property. I hope I'm not talking too fast. Okay, so another property of cathode ray, number 6, is that cathode rays, they travel in a straight line. This is this one comes out a lot in exam cases. They travel in a straight line. So cathode rays travel in a straight line. You will never see cathode rays having a circular motion or deviating in different paths. Cathode rays always travels in a straight line. That's an important property. Now, but even though they travel in a straight line, they can be deflected. They can be deflected by magnetic and electric fields. So cathode rays can be deflected by electric field and magnetic field. So that is very important for you to note here. Okay, so I would like you to, let me give you 5 seconds to write this. For those of you still writing, I guess it is going to help you. So just few seconds, please. Okay, I can see somebody saying I'm fast. So, to go through it again the second time. Number 1, cathode rays are streams of electrons. I already told you they are electrons. And secondly, they come from the cathode. They emanate from the cathode. That means their source is the cathode. That is why they are called cathode rays. their source is the cathode. And remember, you heat the cathode and electrons are emitted. Don't forget that. Then number 3, they are negatively charged. So cathode rays are negatively charged simply because they're electrons. Electrons are negatively charged by nature. That's one of the properties of electrons. Then number 4 is that they can cause certain substances to fluoresce. I think I explained the issue of fluorescing. To fluoresce simply means to give light. So this is how cathode ray. There are certain materials like example of such materials can be, let's say, anthracene. Anthracene. Example of such materials. Once electrons hit these materials, they begin to shine light. They are very bright. Okay, that's the principle they use in making fluorescent tube in those days and discharge tube. I'm going to discuss that after now. Then the 5th one I mentioned is that it can cause it can ionize certain substances. To ionize simply means to cause it to have charge. You know, there are different ways you can ionize. To ionize simply means make it charged. Okay? To make something charged simply means you are making it either positively charged or negatively charged. So, when electrons or cathode rays hit a surface, one of the things it can do to that surface is it can make it charged. And the charge, like I mentioned, can either be positive or negative. Then number 6 is an important one, that cathode rays, they travel in a straight line. Cathode rays travel in a straight line. But even though they travel in a straight line, anytime they encounter magnetic field or electric field, they can be deviated. So cathode rays can be deviated by magnetic field. Cathode rays can also be deviated by electric field. And the simple reason is because they are charged. Now, but I want to say something here before I move to the next thing. Very important. I want to say something. And okay. Now, if I have a magnetic field, now please take notes, you know. If I have north and I have south and I have cathode rays coming this way, remember they travel in a straight line. Immediately they come in between this magnetic field. The cathode rays, which are negatively charged, are usually attracted to the north. That's an exam question. They are usually attracted to the north. Cathode rays are usually attracted to the north of a magnetic field. Magnetic field is generated when you have between north and south pole. So this is north pole of a magnet. This is south pole of a magnet. And so when it is coming, once it gets to this field, it deviated. And the deviation is always towards the north. Okay? Now, the next is, maybe, let me give you guys some time to write. I have a note there.
What time the class ends?
Okay. If you're asking what time the class will end, I think in the next 30 minutes, 9 to 9:30, the class would end. Okay? So we just have like about 30 minutes to 1 hour for the class to go. Yeah. So this is how magnetic field is generated. North pole, south pole, magnetic field is generated. Magnetic field always move from the north to the south. And now you can see, this is, let me call this cathode rays. Now, but underneath, I will call it electrons, because cathode rays are simply streams of electrons. Okay, and as they go, once they encounter magnetic field, they will always deflect, but the deflection is always towards the north pole. Don't forget this. Then when we deal with electric field, let's say I have a positive plate and I have a negative plate, electric field will be generated. Electric field almost move from positive plate to negative plate like this. Okay, that's how electric field is generated. Now, whenever cathode rays is coming, it travels in a straight line, remember? But once it enters an electric field, it will always be deflected towards the positive plate. That is the deflection of. So in an electric field, it is always deflected towards the positive plate, but in a magnetic field, it is always deflected towards the North Pole. Okay. So for those of you writing, I'm going to give you time to write. I know I'm kind of fast, but I'll be leaving the video for some time, you know, for those that may want to go through it, but I'll be taking it down after just 24 hours. Okay. So I want to move to the next thing. Okay, I heard somebody's asking. By the way, after today's class, I'm going to be dropping a link to a WhatsApp group for all the participants. A WhatsApp group. I'm thinking Telegram, WhatsApp, but we are going to start with WhatsApp. I'm going to drop a link so that everybody can join. There we can discuss more. You can ask your questions more. Now, somebody asked the question, why is it deflected towards the North Pole? The reason why it is deflected towards the North Pole is because the North Pole acts as a positive charge. The North Pole of a magnet simply acts as positive charge. And the South Pole of a magnet simply acts as negative charge. And let me talk like an African. God made it so. So it is for you to know that, right? Right? It is for you to know that. So that is quite important for you to know. Okay. So I want to move to the next thing. I hope I can clean up now. Okay. Now, the next we are going to look at is what we call the discharge tube. The discharge tube. Now, the discharge tube also operates under the principle of cathode rays. But the discharge tube tells us something very, very important. And it is actually what is used in creating the fluorescent bulb I explained earlier. Now, the discharge tube looks like this. You have this. Permit me to draw this. My drawing may not be that perfect, but permit me to draw this. Okay? So here we have the cathode. Remember, the cathode will always be connected to an electric source. The source of the heat, whenever a question is asked, is electricity, or you can say high voltage, okay? Then, there is a space here, a little opening here. This opening is to vacuum pump. I'm going to explain why. This opening is to vacuum pump. Now we have the cathode. Remember, you must have anode, you know, cathode and anode. Very important. And that is quite important. Okay. Okay, so now, and there's definitely a connection between the cathode and the anode, you know. That's, by the way, that's how the heat is generated. Okay, so you are going to have, once electron is emitted, electrons move from the cathode to the anode. Don't forget that. Now, you may ask, why do we need a vacuum pump here? The vacuum pump here is to reduce what we call gas pressure. The vacuum pump reduces gas pressure. That means whenever there is too much gas, this experiment is what helps us know at what temperature or the conditions at which gases conduct electricity. And it is discovered that the best way gases conduct electricity is at low pressure. The pressure must be low, then the voltage must be high voltage. That is an exam question. At this time, clock it, you know. So low pressure and high voltage, the two conditions for gases to conduct electricity. And the experiment, the discharge tube experiment, helps us to confirm this, that at a very high voltage and at a very low pressure, gases conduct electricity. This charge begins to glow. That's how fluorescent tube is created. And if, you know, we have a lot of Gen Zs now, so may not know what fluorescent tubes are. But you notice that if there is a crack in any of the tube, light can no longer come. You know why? Because there is a space for air to enter. So that kind of experience will no longer be possible. So for you to enjoy the discharge tube, or for it to be effective, it means that pressure needs to be evacuated. Air, you need to evacuate air or gas from here. Make sure that the pressure here is very low, and make sure that the voltage applied is very, very high, and that will give birth to, you know, fluorescence. This is what we call it, fluorescence. So this is all you should know as far as your exams are concerned about this. And let me also say this. I have seen a question, how do you connect this? Connection is always cathode to cathode, anode to anode, or let's say positive charge to positive charge, negative charge to negative charge. Okay, that's by the way. We are done with the discharge tubes. So we've seen cathode rays, and now we've seen the discharge tube, and I'm about to go into the next thing. Are you ready? Are you ready? Let me give some of us a few seconds to draw this. Okay, so I think I can rub off now. That leads us to the next. Like I said, towards the end of the class, we are going to go through some past questions, WAEC past questions, JAMB past questions, and the like, you know, to follow through. So I'm going to rub this off now. Okay, like I said, you can take your time to go through the videos. I'm going to allow the video on for 24 hours, then take out the video. Okay? So you have 24 hours to, you know, do all you need to do with the video. I'm going to continue with the next thing. It's called another application of thermionic thermionic emission. It's called diode valve. And this diode valve is also called thermionic diode. Actually, it is not only used for diodes, it's also used for triodes, you know, but that's not your scope. So we are not going to be talking about that, triodes. Nobody's going to mention this except maybe under semiconductors. So the question is, what is the job of a diode valve? Now, a diode valve is a device that acts as a rectifier, especially a rectifier. That's the job of a diode valve. And what does a rectifier do? The rectifier simply converts AC voltages to DC. That's what the rectifier does. And I'm going to explain why this is so. Okay, so diode valve majorly acts as what? A rectifier. Now, I want to say something here. This is another topic. Under semiconductors, there is something we also call PN junction diode. That is also a diode which also acts as a rectifier and which also converts, of course, as a rectifier, it converts AC to DC. But when we get there, because that is, the semiconductor is an advancement to this. Remember, I told you that this technology is no longer relevant. The reason is because heat is involved here. You need to heat up the system before the system works. And we've gone far. It's no longer that way now. Okay? So a diode valve, like I said, acts as a rectifier, and the job of a rectifier converts AC to DC. Now, you're going to ask me, how does it achieve this? The reason why it achieves this is that it allows current to flow in only one direction. The reason why it achieves this is because, and you can note that down, that's an exam question, it allows current move in only one direction, and I'm going to explain that further. The difference between an AC and a DC is that DC is called direct current, DC current moves only in one direction, but AC current moves in reverse direction. It can go from left to right and also go from right to left. That's what makes it an AC current. And in all fairness, there are certain devices that operate with AC current. As a matter of fact, the supply of current from Kainji Dam is AC. We only have certain devices in our houses that now convert it to DC, because there are also systems that need DC to function. Okay? Like our iron requires a DC current. Our television requires a DC current, not an AC current. So that means in most of the devices and in many of our houses, we always have rectifiers. The job, and in many devices, the job of rectifier is simply, whenever it detects an AC current, it converts it to a DC and makes it useful. But those devices that uses AC current, no wahala, moves with AC current. There is also something that can convert DC to AC, but that's a talk for another time. I hope I'm making sense. I hope I'm not. Okay. So this is what a diode valve looks like. It looks exactly like the discharge tube. The only difference now, my drawing is, the only difference now between a diode valve and a discharge tube is that there is no vacuum pump. There's nothing to evacuate air. So it's already fitted. That job has been done. Then you have, let's say you have your cathode here. Then here you have your anode. This is exactly what happens. Now, this is how it operates. If the anode is positively charged, electrons, cathode rays is what releases electrons. And remember, I mentioned last time that electrons, or earlier, not last time, electrons are negatively charged. So when electrons are emitted, they go from cathode to anode this way. This is how electrons travel. Because this is positively charged, electrons being negatively charged are attracted towards the anode. Now, but if this anode becomes negatively charged, for example, it means that electrons are also negatively charged, and so we keep repelling. It will not function. You see the reason why it can act as a DC? It can allow current move in only one direction. It can never allow current move in a reverse direction. So because it can only allow current move in one direction, we say it acts as a rectifier. That is all you should know about thermionic diode. Okay? And don't forget how our cathode rays produce heat. Thermionic means heat. So that is it for that one. I hope that makes sense. Okay. If you have any questions, you can ask quickly. I want to move on to the next one. I want to move on to the next one. Okay, I have some minutes left. Wow, this is quite... remember, like I said, I have to say that again. If maybe you missed certain things, you don't need to worry. I'm going to leave the video on my wall for the next 24 hours. Oh, sorry. So you have 24 hours to go through it. So I had my markers for. So you have the next 24. You have the next 24 hours to go through it. Okay. And so that leads us to the last one we are going to look at. It's called the cathode ray oscilloscope, or the cathode ray tube. Then we can see exam questions and we are done. You see, quite fast. Cathode ray oscilloscope. Cathode ray oscilloscope. Let me give a rough sketch. You know, this is what it looks like. I'm in my drawing. I think it has a cathode like this, of course, as usual. Then it has anode. Cylindrical, these are anodes. And these are cathodes. Okay, then somewhere here it has plates, deflection plates. Permit me to do it this way, like this. Then we also have another one this way. Then we have the screen. Well, my drawing doesn't look it. Let me get a better drawing. Give me a second. I think I'm missing something, so I just need a perfect drawing. Okay, I think I make sense. Okay, I need to change this, please. So I'm gonna have something like this up here. And I have something like this down here. Then I have something like this here. And something like this permits me. Then we have this. Okay. Then, okay. The fins. This cathode, anode, that's plates, white plates, on the screen. Okay, that is what it looks like. My drawing is not that perfect, but I'm going to give you time and explain what each of these are. So I want to give you time to study this before I continue. Okay, so now I want to quickly help you see the uses of cathode ray tubes or cathode ray. This is cathode ray oscilloscope, but the device inside it is called a cathode ray tube. Now, I gave a description of the TV of those days, it's quite long, a long box. Or, these days we have flat screens. That's because of advancement of technology. But in our days, the box is long. That is, if you have ever opened that, what you will see looks exactly like this. That is how it is produced. It is used to project. That's why you have a screen. The person on the other side of the screen is watching movies, watching things happening, but don't know the mechanism behind how that happens. It is thermionic emission that makes that happen. So you see your television screen, you see desktop screens too. Those desktop of those days, these days now we have flat screen desktop, but in those days it's quite long, that's exactly the principle behind it. And we have several aspects. Now, the whole of this cathode ray oscilloscope, please, this is an exam question, take note of this, is divided into 3 major parts. The first part is what we call electric guns. Electron gun. So the job of the electron gun is to shoot the electrons. The electron actually moves like this until it gets to the screen, There is a way, very soon I'm going to show you how that magic happens here. Okay, so this first part is called the electron guns. Then this second part is called deflection plates. I've seen wire questions where they draw this, they just drew a rough sketch. And they put this part A, put this part B, then put this part C. This part here is the screen. So, and they ask, what is A, what is B, what is C? Very simple. A is electron gun, B, deflection plate, C is screen. Are you with me? Now, sometimes, especially for those of you writing JAMBs, of course, WAEC, you have objective questions. Sometimes you may be asked, what are the uses of each of these components? And that is what we are about to discuss. Okay, let me find out who is talking. I want to give you time to write this down so that we can talk. Okay. I can see I have some fans here. Thank you for saying hi. Thank you. I forgot to thank everybody for joining in, and thank you. Okay, we have just very few minutes left, so let me quickly explain this. Now, if you notice, the first thing you will notice here are the fins. The fins. The job of the fins, actually in the real sense, the name should be called cooling fins. Cooling. That's the name of the fins. The name should be called cooling fins. So remember, you have to heat the cathode. So that means the cathode is always very hot. You know, Gen Zs are enjoying now. In those days, when you turn on TV sets, the cathodes, the TV box is usually very, very hot, you know. But technology has advanced. We should thank Thomas Edison, you know, and all of them for this. Okay, so the cooling fins is to calm the head down. You know, cathode is always hot. So the cooling fins, after electrons are emitted, the job of the cooling fins is to calm it down. Okay, no, not torchlight. I know torchlight looks like this, but not torchlight. I already gave you an example. Your TV, those days, you know, some of you should visit electrical shops, you know, electrical shops, you know. You would see some of these things I'm talking about. And some of these shops that sell old school desktop is long. I don't think it's sold now. You know, I usually say something, it will take Gen Z a lot of time for them to understand some of these things, because in our time, as you read it, you can see it around you. But, you have to try to use your brain. But some of you have some scraps at home. You can look at it. Okay, but not torchlight. Torchlight is another thing altogether. Okay. So cooling fins to cool it down. Cathode rays, of course, the job is to produce the job is to produce electrons, to produce cathode. You can see the electrons moving, you know. Then we have the anodes. The job of the anode, please, these are exam questions, so you should be noting them down. I want to say this, if you are used to my classes, especially for those, if you have people, you can ask people that know me for years now, you know, over 20 years I've been teaching. Whenever I say something in class, take it seriously, write it down. It's an exam question. And so usually when students are done going through my classes and they enter the exams hall, it looks like nothing, because these are things that Life Changer already taught in class. So I already mentioned what cathodes are. Their job is to produce the electron. All you need to do is to heat it, connect it to a voltage, a very high voltage, and heat it. Once you heat it to get to a particular energy level, electrons will be emitted. So that's the job. Now the job of the anodes here have two jobs. The first one is it serves as a focus. What that means is that it helps to focus the electrons. Hello, are you with me? It helps to focus the electrons. Then secondly, it also helps to manage the voltage. The first one I mentioned, it helps to focus the electrons, and it also helps to, let me not use the word manage the voltage. It helps to accelerate the beam. That means to accelerate it. And the way it accelerates is by the high voltage. The higher the voltage, the faster the electrons become. Okay? And that is the job of the anode. So the electrons come from the cathode. The job of the anode is to accelerate it, to make it move very fast, and to focus it, to give it direction. Hello, are you with me? Okay. And of course, then you have two plates there. You have the Y plate and the X plate. The job of the Y plate is to deflect it vertically, to deflect the beam vertically, to deflect it. The job of the X plate is to deflect the beam horizontally. I need to confirm something very quickly. Give me a second. Okay, I want to say this. You have the Y plate before the X plate. So this first one are the Y plates, and the second one are the X plates. So kindly note that. So the Y plate deflects vertically, the X plate deflects horizontally. Now the reason for the deflection is that Without these plates, this is the problem. You know, I've seen some things. Anytime I'm talking, I'm teaching, I already have a picture in my mind because I've seen some of these things. But I hope some of you can understand what I'm talking about. If there are no Y plates or X plates, it means that the electron will move straight to the screen and will produce only one spot, a dark spot. Where in a case where you see a screen, it is blind, but just a spot at the center is not useful. So the only way the X and the Y plates are useful, the only way the electrons are useful is by putting X and Y plate deflection. The deflection, both horizontal and vertical deflection, produces several frequencies, produces several time series, produces several wavefronts that gives us the beautiful picture we see on the other side of the screen. It's amazing, you know. Sometimes you may not be able to explain it all, but that's the best explanation I can give to this. And that's the reason why, very good. Some of you may have watched movies. Why I'm saying watch movies, I'm sorry, because some of you have never seen them before. Some of you may have watched movies where somebody's on the hospital bed and there is this structure or there is this device that reads the heartbeat that keeps going pam, 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 pam. That is the job of this. Those heartbeats, those readings, is as a result of the deflection of X and Y plates. They create waveforms that gives expression. So the scientists can look at it and say, okay, this going this way means this. This going this way means this. This is beautiful. It's amazing. One of the best discovery of sciences. Okay, and of course, the screen is where that's where the image is formed. So that is it for this one. I think we are done. I think we are done. Okay. So let us see. Let me see. Can we get some questions? Give me a second. Maybe one or two questions. I have a lot of questions here. Let's see. Okay, look at this question. I may just do one or two. We are going to continue on the WhatsApp group. Like I said, I will be posting the WhatsApp group for those of you that are willing to join for these free classes, for further interaction and questions. Okay? So look at this JAMB question. This is a JAMB question. It says, cathode rays are A, high energy electromagnetic waves. Cathode rays are A, high energy electromagnetic waves. B, protons. C, stream of electrons. D, neutrons. E, radio waves. A, are high energy electromagnetic waves. B, protons. C, streams of electrons. D, neutrons. E, radio waves. Bring it on, bring it on. Bring it on. Okay, somebody's asking, can you put magnifying lens instead of X and Y plates? Lie. Don't try it. No. Somebody's asking, can you give us the proper definition? Property definition, what does that mean? Yeah, for the person that say streams of electrons, that is of course the answer. Cathode rays are streams of electrons. They are none of the above. Okay. That's the much I can see. But let me get more questions. Just one more or two more questions. We are going to do more. In the group, we are going to be answering a lot of questions. I'm going to be posting more questions, you know. It's going to be interactive. But let me see one of them, another one. Oh, I wish. There are a lot of questions I'm seeing here, but they are theory. I want just objective questions. Okay, look at this question. Listen to this question. Like I said, we'll continue. This will be the last, you know, so that we can go for the day. Under what conditions are cathode rays produced in a discharge tube? Under what conditions are cathode rays produced in a discharge tube? Okay, A says high pressure and low voltage. A, high pressure and low voltage. B, high pressure and high voltage. C, low pressure and low voltage. D, low pressure and high voltage. I repeat the question. Under what conditions are cathode rays produced in a discharge tube? A, high pressure and low voltage. B, high pressure and high voltage. C, low pressure and low voltage. D, low pressure and high voltage. Let's see. Very good. Very good. Somebody's on fire. You're asking the question. The question says, under what conditions are cathode rays produced in a discharge tube? Under what conditions are cathode rays produced in a discharge tube? A, high pressure and low voltage. B, high pressure and high voltage. C, low pressure and low voltage. Then D, low pressure and high voltage. And I think somebody already has the answer there, which is low pressure and high voltage. Okay, thank you. I think we have come to the end of today's class. Thank you for all that joined in, all that commented, you know, and like I said, this class is going to continue every Tuesday, so get yourself ready. And it's going to continue until you write your exam. This is my community service, right? A kind of a community service. As time goes on, I will be talking more to us. And like I said, I'm going to be dropping a link, a WhatsApp link on the group, on this very, I'm going to pin it on this video. The video is going to be here for the next 24 hours before I take out the video. So you can use it, you know, you can go through it again, you can download as it fits you. Then I'm going to take it away after that. I think that will be it. If you have any further questions on the group, you can post it on that group. And that will be it. Thank you very much. I'll have to go now. Let me go and rest. It's been a hectic day. Thank you. Have a nice day. See you tomorrow.